Hello, today we'll be talking about a 2021 GMC Terrain and its fuel system. This Terrain uses direct injection and also is an electronic returnless fuel system. As a low-side pump, it uses the new 3-phase brushless motor pump. This system uses a fuel pump control module that is located underneath the vehicle to control the low-pressure fuel pump within the tank. This system utilizes a solenoid-style injector, which is pictured up top, while the bottom one pictured is a piezo-style injector. One advantage of GDIs is fuel itemization. As we can see, it is almost 15 times smaller. Pictured here is the fuel rail from our GMC Terrain. The next couple of slides will show wiring diagrams relating to our Terrain. In this video, we can see that the injectors run circuit status test continuously throughout the vehicle running. One of the more common tests is a fuel injector balance test. These are the instructions given to us from ALLDATA that show us how to perform it. This video coming up will show us the performance of the test. As we end up seeing, all cylinders are real close in pressure drop, meaning that all injectors are working as they should. The next test, we will be disablling fuel injectors and monitoring the misfire counters. As we can see, when we disable cylinder 1, the misfire counter picks up multiple misfires. But eventually, when we enable the injector, the misfires stop and go away. In this video, we will be using the command option to command the high pressure fuel pump to increase pressure. Please watch the pressure relation compared to the injector duty cycle. Next, we will be checking injector resistance. In the video, we end up having a little bit of a higher resistance than the chart shows of 1.7 ohms. Pictured here is the injector connector, and here is the connector view from the harness side. Now we will be showing you examples of what we should see on the picoscope versus what we actually saw on our GMC Terrain. As we can end up seeing, it eventually looks pretty similar to what we should expect. Here we are in the 2021 Terrain. We've disabled the high pressure fuel pump and we're going to start the vehicle to see if it will still start. So we can see that the vehicle did start and we do have reduced power. Coming over to the scan tool, we can see that the short-term fuel trim is lean, but the vehicle still will run without the high pressure fuel pump. This means that the solenoid in the high pressure fuel pump is normally open. If we had a normally closed solenoid, the vehicle would not start at all. Now let's move to the low pressure fuel pump side. As you can see, we have something new and interesting about this fuel pump. It is a 3-phase brushless motor fuel pump. In the upcoming video, they will show us how to back probe the fuel pump control module using a lab scope and what we should expect to see with this 3-phase fuel pump.
We located the module attached to the vehicle floor on this model. To begin the diagnostic setup, we first need to back probe the correct pins on our connector. The pins required are pin 8, the gray wire, pin 9, the yellow with gray tracer wire, and finally pin 24, the white with brown tracer wire. Once the probes are secure, we can then attach the leads from our scope. Pin 8 will show on the scope as the green signal, pin 24 will be seen on the red signal, and finally pin 9 will be viewed on the blue signal. We will start our scope pattern check on our 3 wires in a compressed signal format. As the engine is started, our signals are hard to define in this way. They appear to be similar, but too crowded to be sure. We will adjust the sample rate from 5 milliseconds per division to 2 milliseconds per division. This makes the pattern easier to see for any glitches in each line, but we will continue to reduce the sample rate until we have the best view possible of each pattern. Once we have the pattern large enough to see the true image of the voltage rise and fall, we can pause the scope to inspect individual patterns for glitches or missing signals.
3-phase brushless pumps have been used since 2011, mostly on imports. Since 2018, more of these pumps have been installed on domestic vehicles. We are noticing more of these pumps today due to the motors not having brushes, which will in turn have less maintenance on them.